I see a question over there.
Question for Brian. First of all, certainly agree with your policy recommendations in terms of what we do here and what's going on in China. But let me ask, hypothetically, let's say that we had some consortia here in California that could accelerate our efforts in terms of having the budding technologies be able to be scalable. When we then license them for manufacture in China, for domestic consumption in China, how do we protect ourselves in light of those firms, in light of our technology in terms of the reverse engineering and IP that Ignatius was speaking of? How do you prevent your firm from becoming a captive of the many stories where municipal government in China will overtake it? So.
Who is that meant?
Was it for you?
That's for Joseph.
Oh, I'm sorry. The question was, how do we protect ourselves? Again, it really is the working with good lawyers, working with good partners, and the technology. We actually do the chip technology and manufacturing here, and send the sensitive portions to China to be assembled in the wholesale package. So we try to bifurcate initially, but recognize fully that we're in an industry where that very quickly you can lose that IP. So I mean, the bottom line is that you can buy a knockoff Apple phone in China for $30. The reality is that it's not the real phone, and it's not going to work as well. And so you just have to focus on, once the technology is out there, making sure you stay on top of it, run it hard, protect it thoroughly through good counsel, and make the best possible product and be behind it all the time.
Thank you. I think we have time for one more question. Otherwise, our panelists will be out, I think, for cocktail hour with everybody can answer questions over wine. Do you have one more question over there?
Yeah, hi. This is for the panel. Anyone can answer who would like to weigh in. There seems to be a need to kind of connect the dots between electric vehicle deployment, smart grid technology, distributed generation, particularly on the renewable side, and energy storage. And I'm just wondering if the panel could comment upon what they've seen in China and India as compared to what they see in the U.S. in terms of trying to connect the dots between all those different elements.
I can tell you in China that they're way ahead of us in terms of trying to push storage as being a component of the charging infrastructure. And that India seems to be ahead of us, ahead of China in the smart grid side. So everybody recognizes that the electric vehicle is going to be a paradigm shift in consumption, and that the whole cycle is going to be necessary, from storage to interface with the grid, to time of charge. I mean, the smart grid is going to allow the utilities to tell you when they're going to charge your car. And I think that's going to be a big paradigm shift. So I think that China and India are on par with us right now. But China, through the state, is really pushing very hard, through the state grid, is pushing very hard to control car charging.
Let me say, if you look at the grid, there are two parts to the grid. There is the high voltage transmission side, and there is the distribution side that is in the cities and so forth. And in the U.S., so I would not necessarily agree with all the comments. I wouldn't say that India is that far advanced of the U.S. I would say that U.S. is ahead of India. But I would also say a few things. I don't think it matters who's ahead right now. I think all of us are trying to get somewhere. And I think that we have to figure out where we need to get and how do we get there. What are the key components you mentioned? You mentioned renewables. You mentioned energy storage. Okay. The third thing, which you didn't mention, is something called demand response, that basically allows the utility to connect to the consumer, to be able to ensure that during peaks, they're able to turn switches off and have the consumer participate along with the utility, and thereby making an intelligent grid. The point that was mentioned was using electric vehicles. So in UCL, as part of our demonstration, we want to integrate a large number of electric vehicles and aggregate them and showcase the capability of what's called back charge, that is called vehicle to grid charging, i.e. at 1 p.m. when the utility is running short of power, take that energy, make it available to the utility. So those are the kinds of things that are being experimented, but there are not that many electric vehicles on the road today that you can aggregate all that power today and do things. So we, for example, in UCLA and other universities and research labs and DOE labs, we simulate, we assume that there's these vehicles, and when they happen, when you aggregate them, how can you then balance the demand and supply on the grid? So there's a lot of very complicated questions, and I think that it's not as simple as they're ahead or we are ahead or something like that. That's my opinion.